So if you are following along in your book, it tells you, it has a big table and tells you there are reciprocal identities. And this is not something new. We've already been using it. We already know if I have sine, what's the reciprocal of sine? Cosecant. And vice versa. If I know cosecant, I can just flip it and I get sine. So it's up to you if you want to write these down or not. We've already been using this fact. I already told you this in the last section and we've used it. Sine and cosecant are reciprocal. So if you know one, you just flip it and get the other. Same for cosine and secant, tangent and cotangent. So that's the first property we're using in this section, which is nothing new. The second thing has to do with a notation and something on your calculators. So in the next chapter we will talk more about using a calculator, but I want to go ahead and make a mention of this now. In algebra, we use -1 to mean the reciprocal of something. That is not the case with these trig functions. When we are looking at our calculator, it has sine, cosine, tangent buttons. And above those you see sine -1, cosine -1, tangent -1. It does not give you the reciprocal. So if you want the reciprocal, you actually have to type in 1 divided by whatever. Don't use those -1 buttons for now. We'll learn later on what those do and how to use them. Alright, so if I give you that tangent is equal to, or cotangent is equal to 4, can you tell me what tangent of theta would have to be equal to? 1/4. They are reciprocals. If you have an integer, this is just like 4/1, so the reciprocal is 1/4. Alright, if cosine is -2 over the square root of 20, what is secant going to be equal to? Radical 20/2. We don't change anything except we flip it. Now I would expect you to go ahead and reduce this even though the original answer wasn't reduced. How would we break apart a square root of 20? Square root of 4 is 2. So those 2's cancel and we get a negative square root of 5. So some of our homework questions are going to be like this. Make sure that your final answer is in lowest terms, even if the original numbers they gave you were not. Alright, is that okay? Second thing I want to talk about. We did this, you had some questions on your homework that we turned in today, and it would say things like, in quadrant 3, y/r, and you would tell me if this was positive or negative. So we can extend that and talk about for each quadrant which trig functions are positive or negative. So we're going to fill out a little table. I'll give you a second to draw that in your notes. So we can relate this to the definition. What is the definition of sine? y/r. Cosine. x/r. Tangent. Cosecant is the reciprocal of sine, so it would be r/y. Secant is the reciprocal of cosine, so r/x. And cotangent is the reciprocal of tangent, so x/y. Alright, in quadrant 1, if you take any point, think about algebra, your x is positive, your y is positive, and we know that r is always positive. So in quadrant 1, what's going to be true about every one of these ratios? Every one of them is positive, because all three of our numbers are positive. In quadrant 2, is your x value positive or negative? negative. And our y value is positive. Okay, so y divided by r, y and r are both positive, so that's still positive. And if sine's positive, that means cosecant is also. Cosine, x over r, so a negative over a positive would be negative, which means secant is also negative. Tangent, y over x, so a positive and a negative makes negative, which means cotangent is also negative. In quadrant 3, x is and y is, alright, so y over r would be negative, which means cosecant is as well. Cosine, x over r would be negative, so secant is as well. Tangent, y over x, negative divided by a negative, positive, so cotangent is as well. In quadrant 4, x is positive, y is negative. So y divided by r would be negative, so that means so is cosecant. Cosine x over r would be positive, and tangent y over x would be negative. So we can notice a few things. Each of our trig function is positive in 2 quadrants and negative in 2 quadrants. A shortcut for remembering this. I always tell everyone to use all students take calculus. So in quadrant 1, A for all. What this tells me is in quadrant 1, all trig functions are positive. Quadrant 2, S is for sine. So that means sine is positive. And if sine is positive, which other one is? Cosecant. That means the others are negative. Look at your table. Sine and cosecant were positive, everything else was negative. T. What do you think T stands for? So in quadrant 3, tangent is positive, and we know then the reciprocal is as well. We look, tangent and cotangent were positive, the others were negative. And the 4th quadrant, C. What do you think that stands for? So in the 4th quadrant, cosine is positive, which means its reciprocal is as well. And the other 4 are negative. So all students take calculus tells us which trig functions are positive in that quadrant. Any questions there? Let's practice using this. So I want to know the signs of the trig functions. I'm just going to cheat. I'm going to make this into a table so I have. So we have. So to decide if the trig functions are positive or negative, all we really need to ask ourselves is, what quadrant am I in? So 54 degrees is in what quadrant? 1. So think about our trick. All students take calculus. In quadrant 1, what's true? They're all positive. $260. So we think this is 90, 180, 270. So 260 is between 180 and 270, so that's quadrant 3. In quadrant 3, what's positive? Tangent, and if tangent is, so is cotangent. It means everything else has to be negative. Right, negative 60. What quadrant is that in? If you don't like the negatives, what could you do? You could find the coterminal. 300, so 0, 90, 180, 270, 360, so that's between 270 and 360, so that's quadrant 4. Quadrant 4, what's positive? Cosine, and so it's reciprocal secant, and the other 4 are negative. So if I gave you a trig function and a quadrant, could you tell me if it's positive or negative? Okay, it's another skill we will use daily as we go through this semester. All right, so using that, I want to see if we can figure out what quadrant we would be in for each of these things. Take a second and look at it yourself. If I say tangent of theta is greater than 0, what does that tell me? It's positive. Okay, so if I think about my quadrants, all students take calculus. I told you that every trig function is positive in 2 quadrants and negative in 2 quadrants. If tangent is positive, can you tell me which quadrants we would have to be in? We'd have to either be in the A, where they're all positive, or in T, where tangent is positive. So I already know right now it can't be quadrant 1 or 4. Right. Then it says cosecant is less than 0. Cosecant is the reciprocal of sine. So if you want, you could think this even means that sine is less than 0. So less than 0 is negative. I know I am in one of these 2 quadrants. In quadrant 1, they are all positive, so could sine be negative there? No. In quadrant 3, tangent is positive, so could sine be negative? Yes. So the correct answer here is quadrant 3. That is the only quadrant where tangent is positive and sine is negative. Look back to that table where we put all the positives and negatives, and double check that. In quadrant 3, tangent is positive and sine was negative, so we figured it out. All right, B, sine of theta is greater than 0, so that's telling me sine is positive. In which quadrants is sine positive? A and S, so I know it's not in 3 or 4. Cosecant is greater than 0. Cosecant is the reciprocal of sine. So it's still telling me sine is greater than 0, so it's the same 2 quadrants. So this one I have 2 answers. In both quadrants 1 and 2, sine and cosecant are positive. Does that make sense? Let's do, so we have to kind of break this section apart, right? Do part each day. So let me do one last thing and then I'll probably stop there for today. I want to talk about what kinds of answers can I get for these trig functions. So the ranges. You know, when I find sine of theta, is any answer in the world possible? Or can I only get certain types of answers? So think about this x, y, and r definition we've been using. Okay, we know that we're talking about an angle. And I'm going to keep it in the first quadrant now for just a minute. And so we know when we're looking at x, y, and r, this is my x, this is my y, and this is my r. Okay, so when I look at sine, I am doing what ratio? Y divided by r. Okay, if you're looking at this triangle, is there any rule if x or y has to be bigger? No, it could just depend on my angle. Sometimes x will be bigger, sometimes y will be bigger. How does r relate to those? It's the hypotenuse. And we know that in a right triangle, the hypotenuse is always the longest side, right? So if I'm going to take y divided by r, I know that my denominator is bigger. So if you take something and you divide by something bigger, are you getting an answer more or less than 1? Less than 1. Now, we've also seen, is it possible for sine to equal 0? Like when we're laying on the x-axis. And is it possible for sine to equal 1? Like if I'm up here, then y and r are the same. So we can hit 0, we can hit 1, but we can't have anything bigger than 1. Does that seem reasonable? And we know that sine can be negative if we fall in the other quadrants. So sine has to be some number between -1 and +1. Anything bigger than 1 or smaller than -1 would not work. And cosine follows the same rule, because cosine is x over r, and we know that r has to be the biggest side. So this is our range. What values can these functions be equal to? All right, let's talk about cosecant and secant. They are the reciprocals of sine and cosine. So when you do those, your r is now on top. So what kind of answers do you get if the bigger number is on top? Greater than 1. Now again, from yesterday when we talked about those quadrantal angles, we know it can equal 1. So with secant and cosecant, you can have basically the opposite of sine and cosine. Sine and cosine are between -1 and 1. Secant and cosecant is everything smaller than -1 or bigger than +1. It's the opposite because they're reciprocals. Last one, tangent and cosine. Alright, these come from y over x or x over y. And we've already said, x might be bigger or y might be bigger. So is there anything that can't happen? No, so tangent and cotangent can be equal to anything. this is kind of a helpful thing when we're working through problems. You know, if I'm working a problem and I get sine of theta equals 5, is that an okay answer? No, sine can't be bigger than 1. So I know, oh, I got 5, I did something wrong. My answer is incorrect. So last example for the day. If I give you some values, for each of these, I just want you to tell me, is it possible or impossible? So take a second and try it. Is this possible? So can cotangent equal a negative 0.999? Tangent and cotangent can equal anything. Can cosine equal a negative 1.7? No, it can only equal things in between 1 and negative. Can cosecant equal 0? No, it's the opposite sine and cosine. So sine and cosine, think about your number line. Sine and cosine are here. Secant and cosecant are outside that window. So this is not possible. Any questions for me? So, you are good to do this chunk of problems.